So, I'm currently experimenting with geometry nodes in Blender. My goal here was to build a node system for generating scale-like procedural coverings, but not just to control the distribution of individual instances. I wanted to make sure I could also modify the shape of those instances themselves, so that I can achieve a wide variety of surface patterns. For example, decorative lizard scales, bird feathers, stylized fish or dragon skin, or even create forms like shelf fungi or flower petals. To begin, we need to define the area of the model where the instances will be distributed. This can be done using a color attribute or vertex groups. I created a new attribute and then used vertex paint to paint the distribution area directly on the mesh. In the modifier stack, I reference this attribute, and now you can see the generated covering on the object. Each instance is linked to a point on the surface, so at first the pattern looks very structured and perfect. To break up this uniformity, I added a parameter that offsets the instances across the surface, which I exposed in the modifier. This way, the instances can look perfectly structured or more organic and natural, which works great for simulating nature-inspired forms. The core element of this node system is a curve that defines the base shape of each instance. I chose a quadratic Bezier because it's flexible and easy to control. Inside the node tree, you can modify the overall shape of the curve using a float curve node. This affects all objects using this system at once. I also exposed additional curve controls in the modifier, so you can adjust the start, middle, and end shape of the curve. This allows for a wide range of results, from flat petal-like shapes to curled forms or looped structures. The largest block in the node graph handles the distribution and orientation of the instances on the surface. Within this section, you can change the axis used for alignment. This influences how instances are oriented relative to the surface. I also exposed a control for axis orientation in the modifier, so you can easily tweak the direction within the chosen axis. Naturally, you can also adjust the size of instances, setting minimum and maximum scale values. To add more dynamic variation, I included a proximity parameter. This block allows you to use any object to control the scale of nearby instances, adding a layer of natural randomness to the covering. For example, you can create a cube and turn it into a grid, then assign it as the proximity object in the modifier. By moving this cube, you can control instant scaling interactively. This proximity driver can be any mesh, or even a curve for more flexible setups. Of course, the modifier also includes a material assignment for the instances. You can choose any material from your library, and it can differ from the base object's material. Inside the node graph, there's also a store-named attribute node, which helps distribute different colors across instances, but this works in combination with the material setup. This system is still a work in progress, but it already allows me to explore a wide range of organic and stylized surface patterns. I'm planning to develop it further, add more controls, and refine the materials. I hope this overview helps inspire your own experiments with procedural geometry in Blender.